In this video, we're going to test GPT 3.5 Turbo's comprehension over its memory or its context. We are going to store the results. What we are doing is we are inserting a random text into different position in the context. I represents that. And we are seeing at what positions when that text is that it answers correctly or incorrectly. What inspired me to do this is this paper that I saw on Twitter that says that LLMs are better at using info at the beginning or at the end of the input context. So as you see, if the information that you're seeking is in the beginning of its context or at the end, it is able to answer the question correctly, versus if the information is somewhere in the middle, it seems to have some trouble. So we're going to try to validate this. Along the way, we're going to learn about how we can automatically retrieve Wikipedia articles and save its content to a file. How we can use that content to actually separate it into different size contexts using TikToken. Save it to a JSON object. For example, here we have separated into 1000 context, 1000 token context, 2000 token context, 4000, and also 8000. And then we have an automated process which inserts a given text at different position in this context and asks the same question and tries to validate if the answer is correct, and then prints the percentage of correct answers at different context lengths and at temperatures, and also when the text is positioned at different points in the text, and actually saves the results into our JSON file. So this is going to be pretty interesting. So let's just begin. We have this file, getWiki, which actually retrieves a given article, here in this case Egyptian pyramids, retrieves it, uses beautiful soup to get the textual content out of it, and actually saves it to whatever the article name is. Here in this case, I've already done it. I have two examples, Egyptian pyramids and also the Python programming language saved already. But feel free to use this to actually download more articles and maybe expand the testing capabilities of the system. All these files will be available at Patreon for download. The link will be in the description. Our second file is this context generation file, which actually uses TikToken to count tokens. We define token limits. We want to extract 1000 token context, 2000, 4000, and 8000. So then we actually loop over, and until we are reaching those limits, we extract the necessary words out of this content. For example, we select beginning with the word the and Egyptian pyramids. We keep adding them until we reach 1000 context. For example, let's say this was 1000, and we save that to a context.json file with a key 1000, as you can see here. This is saved here, and then we do the same for 2000, which is going to be longer, and then 4000 and 8000, so that we can actually use them later in our QA session. So this is what this file does using TikToken. And then we have the QA auto.py file, which opens that context.json file. We define the context lengths and different temperatures. So we're going to be testing this system with 1000 context, 1000 token context, 2000 and 4000 at temperature 0, 1, and 2. We're going to be inserting x equals 12 into this pyramids Wikipedia article. And then later we can also test it with some regular text as well. Secret word is plum. So we're going to be inserting this x equals 12, whatever text we have selected up there, at different positions in the beginning of the article at first, and then after 100 words. So we're going to be inserting it deeper and deeper into the context. And at each point, we're going to be asking the GPT, what is X? And then we check for answer 12. If it answers it correctly, we keep track of the results, and we write them to result.json file at the end. So let's run this and see what's happening. But before we run this, I would like to mention EcoHive AI Academy at ecohive.live. Here you can search all my videos and find the code download links to the videos that you're interested in learning. It's ecohive.live. I'll put the link in the description. So let's run this. And when we run this, we're going to see, we see that we have first selected that 1000 token context at 12 at 0 temperature. And at the first when the x equals 12 is in the beginning of the context, it actually answers it correctly. And then when it has placed 100 words deep into the context, actually it doesn't answer it. And 200 deep into the context, it still doesn't answer. So actually at the end, percentage of correct answers for context length 1000 and temperature 0.14, 14%. Then we move on to context length 1000 and temperature 1. And when the x equals 12 is in the beginning, we get a correct answer. And I believe not in the rest of time. Actually, I believe we do get one more correct answer. Oh, it actually accidentally. Yeah, I guess it sometimes it did answer it, but it says the 12th language. Anyway, here it's 30%. And when the context length is 1000 at temperature 2, it actually answers it 28%, same. And then we move on to context length 2000 at temperature 0. And the result is very low here, like 7%. Then we move on to 2000 context length at temperature 1. Then the result is again 7.5%. Then we move on to temperature 2. And here, actually, the results increase to 30%. I have realized that as the temperature increases, it tends to detect it better, but then it starts really talking nonsense as well. So there's a bit of a trade-off there. And when we move on to 4000 at 0 temperature, and again, we get 7%. As you see, the accuracy drops with larger context lengths. We are still continuing for 4000 context length and temperature 1. Here are percentages 20% with 4000 and temperature 1. Now this is going to be our final run. 4000 context, token context, and temperature at 2. As you see, there's a lot of jibber jabber. Can't really understand at some point. Look at this answer, for example. These are each individual runs. So its performance degrades a lot at temperature 2, but surprisingly, it actually starts answering better in this case. I just realized something when I was testing this before, that x equals 12 is some kind of a mathematical thing, right? And it really doesn't match with the context of the pyramid article from Wikipedia. And actually, it does say that, based on the provided context, it says there's a reference to x equals 12 in the content, but it's unclear what it refers to. So it has some doubts about it, understands that this is really not related to the article. But it's information that is in there, and we are asking it, what is x? So we are hoping that it could answer it. But actually, it fails quite often. Okay, the final run was actually 38% at temperature 2. As you see, if we go back, at temperature 1, it was 20%, and at temperature 0, it was 7.5%. Now, if we take a look at the results, let's see if this works. Unfortunately, it didn't, but we could actually maybe loop over or something. Oh, okay, I was able to fix it. See, there is this extension called pretty.json, and that we can use. This one right here, I actually have it installed. When you have a JSON file, you can actually select all of it and then do Control-Shift-P. And when you select pretty.json, it actually puts it in a nicer looking format. So as we see at 1000 token length and at 0 temperature, only when the x equals 12 was placed in the beginning of the text, we got a correct answer. And at temperature 1, we got 1 correct in the beginning, 1 in the middle. At temperature 0, we got 1 in the beginning and 1 in the beginning and 1 in the middle. At 2000 context length and at 0, we essentially got 1 at 700 position, somewhere in the middle. At the temperature 1, we got it correct at the end. At temperature 0, we got correct quite a lot in the beginning and nothing after that. At 4000, we got 1 correct in the beginning, 1 kind of still in the beginning, but closer to the middle, and no other ones that were correct. At temperature 1, we got 1 in the beginning, 1 at 500 word, and we actually got 2 correct around 2000 word mark, and 1 correct towards the end. So there wasn't much correct in the middle. At the temperature 2, we get quite a few correct in the beginning. This is still the beginning. A few correct in the middle. And see, we get quite a few corrects in the middle, actually. So just having looked at this, this doesn't really then exactly match with this finding. We did get quite a few correct. This was at a higher temperature. This, I mean, it's difficult to know without actually creating a matplotlib chart or something like that, but it definitely, this is correct, that it actually answers way better if the information is presented in the beginning of the document. The middle and the end, it seemed to me about the same. Now let's do this one more time, but this time let's remove this x equals 12 and bring in the secret word is plum. So we're going to be inserting this secret word is plum into this context, the pyramids context. And our question is going to be, what is the secret word? So we're looking for the answer plum. Okay, let's make sure everything is in order. We are inserting that text. We do have to check for plum in answers. So this should be good. Let's run this again. Okay, 1000 token length and 0. As you see, we get quite a few right. Almost every single one is right. Temperature one as well. So this is really interesting. In temperature 2 at 2000, we are still getting almost every single one of them right. So I'm not sure what to draw from this conclusion. X equals 12 definitely doesn't fit in the pyramids context, but I was hoping it would know the answer. It's still a very distinct bit of information. I believe the API is hanging up right now as we are waiting. So that actually allows me to talk about tenacity. I am importing tenacity and we are doing exponential weight. To be able to use tenacity, what tenacity does is you assign it as a decorator to your functions. In this case, we're making this OpenAI call to GPT 3.5, right? So if for any reason this fails, maybe we get a rate limit error or something like that, then it will actually retry with a minimum of 2 seconds and up to 70 seconds with a multiplier of 1.5, because it is an exponential, what's called an exponential backoff. So each time it will pick a random number between 2 and 70 seconds, and it will wait that much time, since we are saying it to try for up to 3 times. If it fails the first time, then it will go to a second time, and it will multiply whatever number was picked by 1.5, then wait that much longer, and then try again. And then if it fails again, then for a final last time, because we've set this to 3, it will multiply that for 1.5. Then we'll wait for that long, and after that, then the process will fail. An exponential backoff style retry, such as with tenacity, is really useful. You do have to turn your call into a function, and then you have to put the retry, in this case tenacity retry, as a decorator at the beginning of the function. And currently, see, we are waiting. We are currently hung up. If you used OpenAI's API at any capacity, these occurrences are normal. So you definitely have to have some kind of a retry strategy. Now, it would be interesting to test the x equals 12 in the context of Python as well. I mean, because Python is way more mathematical. Maybe we'll do this after this. Yeah, we are still waiting on the API. In the meantime, again, I'll mention Echo Hive website. Here you can actually search for different videos. For example, here we are dealing with, for example, tenacity. If I were to search for tenacity, here, these 2 videos actually talk about tenacity retry, right? So this is really cool. I actually have a video actually talking about how I built this website. I believe search for Echo Hive here. See, this one actually talks about how to build this particular website. I'll also mention the latest app that I built, latest archive LLM paper summaries. So this app actually retrieves latest archive papers on large language models and actually summarizes them into a summary, bullet points, and keywords. It does this automatically every hour, given that there's a new paper at that time. You can actually also click to read the full article at archive as well. essentially, I would like to work in the future from building full stack apps. And actually, if we go to Echo Hive again, this video, the full stack GPT web app, actually talks about how I built the large language, the LAMP Papers app. It includes how to deploy the Railway as well. I'll be making more videos on building full stack apps using GPT API. If you're interested in those types of stuff, please subscribe so that you'll be notified of those videos. Okay, so tenacity retry worked. I mean, we did wait for quite a long time, but we are going now. Again, look, it's always answering correctly. Yep. Now we move on to 4,000. So really, we should fail quite often here. See, at length 2,000, temperature 2, we got 60% right. At 2,000 and temperature 1, we got 92% right. It is interesting with x equals 12. Higher temperatures were producing better results, but here in this case, we are actually declining with higher temperatures. So with context length 4,000 and temperature 0, we got 92% accuracy. Let's see, at temperature 0, 2,000 length, we got 100%. See again, at length 1,000, temperature 2, we dropped down to 60%. And at temperature 1, we were at 71%. And at temperature 0, we were at 1. So this is really interesting. It's something to keep in mind. You can download the code from Patreon and maybe modify it, test it yourself. Maybe you have a critical use case. Maybe you can use something like this to have some measurements. Okay, at length 4,000, temperature 1, we got 84%. Again, it's dropping with higher temperatures. So this is interesting to know. The secret word is plum, obviously maybe fits somewhat within the context of Egyptian pyramids. That is really interesting that GPT sort of requires the content to be some kind of cohesive content. I mean, if you're doing similarity search and retrieving some pieces of context, obviously with similarity search, they should be pretty close to one another, but it's just something to keep in mind. Yeah, as you can see at temperature 0, it's really struggling. But it is still getting quite a few of it. Okay, accuracy was 65%. Let's look at the results.json. Oh, we actually failed to save the result. Oh, my bad. Because when I converted with JSON, if I forgot to save this, and since this file was open, it cannot overwrite it when the situation is like this. Anyway, let's quickly try with the Python text as well. Let's actually demonstrate how we can get it. If we type in here Python programming language and run this file, get wiki, let's see what happens. Python programming language, yeah, nothing there. But it has to be an exact match. I believe the article name actually comes with parentheses. Let's try this. Yeah, this one was correct. You can actually delete this, and I actually had done this before. This is the exact same one. I just changed the name to python.text, so we can actually delete this as well. So this is how getWiki works. The next one is context generation. So if you were to delete this context.json file, which was for the pyramids, okay, and then run the context.gen, then this should create a new context.json. We do have to change the name of the file, right? Let me delete that. Here, instead of Egyptian pyramids, we need to open the python.txt file. And when we run it with python.txt, we create the context.json with the Python content, and we have split it into 1,000 token chunk, 2,000, 4,000, and also 8,000. We're not really utilizing the 8,000. For that, you'd have to switch to the model GPT 3.5 Turbo 16K. It gets pretty expensive. Each run can cost $3-4 or more, so just be mindful. But anyway, what I wanted to do was, we're going to open the context.json, and let's go back to our x equals 12 example, because I'm just curious, because that would be much more similar to the Python context. And let's see what happens. We will be looking for 12 in the response, and I believe that should be it. So let's run this. Okay. So it actually got this right. Okay, so it did much better. Look, we got 60% at first. We had what, 17%? Wow, we actually got 85%, right, with temperature 1. So yeah, so whatever you're asking, whatever information that is present in the context, I guess has to be relevant to the overall context. With temperature 2, we declined. Let's just take a look at the context length 2000 real quick. 35% say this declined with larger context. Okay. Yeah, we'll just end it here. I hope you found this video useful. These files will be available at my Patreon. You can find the code files for over 100 projects on my Patreon. I do spend a lot of time learning quite a lot. I work all day, almost every day, as it is my full-time job, almost. I try to experiment with things and share it with you. And you can find the code files for all the projects that I've created. Thank you for your support, and see you in the next video. Before we end, this was running. Look, it's 2000 temperature 2. We got 21%. And let's see what'll happen at 4000 temperature 02 before we end. And by the way, I have a silly trailer I made for the EchoEye website, so it'll be playing right after this. It has some music in it. I just want to let you know. I try to keep the volume of it low, but this is a warning that you'll be hearing some music here soon. Okay, this should be done shortly. 21% accuracy at 4000 and temperature 0. Okay. Thank you for watching, and see you in the next one.